Hey everybody, this is Deacon Stone with RCBI's STEM Education and Maker programs, coming to you from our home here in Huntington, the Robert C. Byrd Institute. We're celebrating 30 years this year, and I know it's been a very interesting year to say the least. Last year, when we accommodated Gear Up, we were able to cut these wonderful stainless steel coins on our laser cutter, a laser cutter that you'll see in just a little bit. We're going to go inside and take a look at some incredible inroads to STEM careers, careers in machining, manufacturing, welding, CNC, 3D printing, and more. So welcome and thank you for joining us in this virtual tour. Let's take some safety measures here. Go on inside, check out the shop floor, the Maker Vault, and learn a little bit more. Come along. We're here on our shared manufacturing floor with one of our engineers working in the background on one of my favorite pieces of cool equipment here called the wire EDM cutter. It uses erosion to cut through pieces of steel like this, and it doesn't just have power, it has precision. Check this out. These pieces fit together like a puzzle to create the kind of blades that you might use on your trimmer at home when you trim your hair. Look at this beautiful design. These little ingots are cut out and chucked into the machine, and we can slice blades off just like potato chips. I think that's fascinating, and I'll tell you why. Is not just because of the power and the precision that machines like this bring us, but because we always have our eye toward achieving scale. When we can close in on how to produce one thing, we've done a good job as an engineer, as a designer, as a machinist, right? But if we hone our skill, it gets better and better. We can produce more things more efficiently, create opportunities, and create jobs. And we're some of the folks who benefit from those jobs, students just like you, studying in these fields. So we're going to have a unique opportunity as we grow the economy to position ourselves for growth. And you're going to find out as we move along, some of these careers are not only incredibly interesting, but they also pay a great wage, even starting out. Well, it's hard to pick a favorite in a really cool shop like this with tons of pieces of fantastic equipment. This is our 4,000 watt CO2 laser. It uses a laser to blast through steel as thick as 5/8 of an inch. And what's fun about this piece of equipment is it's accessible by folks just like you. So this is a piece of shared manufacturing equipment. We offer pieces of equipment available to clients, individuals, companies, and others as they grow so they can try new things or even produce units in vast quantities to help serve their business. So this fascinating piece of equipment is constantly running. And when we pull things off of this laser cutter, they're often taken straight over here to this multi-ton press where they're bent into beautiful brackets and shapes to create products like you use around you in the world every day. I want to showcase a really cool product that comes from this multi-axis mill from a manufacturing company that specializes in outdoor industry. So they start with something as simple as an ingot of aluminum like this on this machine, right? It gets chucked into the lathe on one side, and a head flies in. It can turn it like a baseball bat. It can carve into it from the edges and take it down to something like this. This hole gets drilled and tapped. These pieces get cut. This hole gets drilled and tapped. The metal, we start off with a block, and we cut everything away that is not the item in question. When we're done, we end up with this beautiful piece of hardware. Anybody know what it is? It is a stabilizer for a compound bow, right? These get hydro dipped, and these get sold from right here in West Virginia. In this area, students studying our machinist trades training achieve certifications in metalworking. We promote these programs in conjunction with local community and technical colleges. And these beautiful old world pieces of machinery are where the real skills are built. Every student starts out with a beautiful hand-operated model like this. If you're interested in exploring careers in machinist trades training, in CNC, in welding, Like, it starts right here. And what's fascinating about it is that there are great careers that are in high demand here. In fact, they're in such demand. 90% of our successful graduates achieve program placement. Now, I'm not saying that about our programs in particular. The fact is that the industry demands professionals with these kinds of skills. The fact is that many of our program candidates are getting snapped up so quickly that, that we had to accelerate the program into an 18-month program. You can get a 2-year degree in 18 months. We're not the only ones doing this, right? There's a critical mission at hand now. You can land jobs starting from $30,000 to $50,000 starting out with an 18 to 24-month program. These are fantastic growing careers that are going to grow the American manufacturing industry. There's intense demand. I came up in Southern Ohio. I'm the child of a single mom, and we grew up on welfare. We had to stand in commodity lines to make ends meet. And I'll tell you, the only way I was able to achieve any kind of traction in life and aim toward having a career or a family or stability was by leaning in on my education. And I feel like a lot of my life started when I set foot on the campus of Marshall University. From there, I achieved access to the third highest ranked Master's of Arts program in the United States. The opportunities here are real if we engage with and lean in on our education.
We train machinists. A machinist is to metal as a carpenter is to wood. We are at the Robert C. Byrd Institute for Advanced Flexible Manufacturing. This is a machinist training, machinist technology program we have. Any type of manufacturing industry needs machining. It's one of those behind the scene things where you were kind of back in the shadows, but you know, any industry there is requires machining of some sort. Teach them the basic skills. They go through the first year learning the manual machinery, the basic skills of measurement, blueprint reading. We hone those skills, you know, to the tight tolerances, the tighter specifications. That reflects the jobs they'll be doing. There's been a dropping away of trades of all kinds. The skilled workers are retiring and there's no one to replace them. We have a really high placement rate here for putting people to work. If somebody's got to want to, you know, that's all it takes. Everybody starts on the same step. This gives you the basic skills. This program is for anybody. We've got students that are right out of high school. We have students that have been maybe displaced from other industries. We're not just teaching them to be machinists, we teach them to be employed as machinists. If we don't produce these things in this country, we're going to have to buy them from somebody. Machinist manufacturing entirely is a big part of our economy. I think there's a big need right now. These students that are in this course are in a really good position. You know, we keep the wheels rolling. We keep the power plants rolling. We keep the pump plants rolling. We keep steel mills rolling. Skilled labor is in high need right now.
Let's check out the Makerbot. So here we are at RCBI Huntington, and our location used to be a bank, and this is the old vault of the bank here. So inside we have a fantastic array of 3D printing and other technologies at work. Tons of projects underway. And lots of cool stations for soldering and tons of different kinds of equipment, including Makerbot Studios back here with a microphone and a camera for you to kind of go mobile and virtualize your content as you see fit. And all different kinds of projects and printers underway in here. Now, one of the coolest things about 3D printing is it's not just for prototyping anymore. We get to use 3D printed objects in the real world, and I got a couple little models here that I can show you guys. I'll tell you what I'm after. This is a piece we made for Toyota. It's solid ABS. This actually gets out on the factory floor where workers can use it to ease their workflow by attaching hoses and things to engines and transmissions. They come down the assembly line at the Toyota Buffalo plant right here in West Virginia. Pretty fantastic, right? I would say, you know, we can print an object on a print bed. It's pretty easy to do. You can print another object right next to it and then pick them up and assemble them These are great for fun, for hobbyists, and to have a blast, right? But if you're going to be able to print more than one object on a print bed, I always ask the question, could you print a chain? And if you could print a chain, why would you go to the trouble of linking the links together after you printed it? Why not go ahead and have the links linked together as you print the chain? We have a chain printed right here. It just happens to be in the form of a little slug. It's a great example of how 3D printing can take aspects of making a project like assembly and integrate them into a single function. When we take all that learning together, we can print objects like this. This is one of my favorites. Technically, it's called a functional assembly. See that? That's actually a single 3D print. It's a print made up of 6 components. 2, 3, 4, 5, 6. And this thing is articulated. It has a mechanism on the inside that makes it function, and it was never put together. This can't be disassembled because it was never assembled. Its assembly was part and parcel to its creation process. And that's part of what is making 3D printing so alluring for manufacturing. In fact, I think it's one of the keys to understanding why it's important to ask better questions like, hey, could you 3D print a car, an ear, a heart transplant piece? Like, yes, yes, yes. And it's being done right now all around the world. The right question is not, can you 3D print it? The right question is, how should it be designed with 3D printing in mind, so we can make an entire mechanism rather than simply 3D printing a bracket or a piece. So that's one of the ways that we think about making these days, and how making is changing, and how manufacturing is shifting, and how the world around us is becoming a richer, more connected place, full of sharing and full of opportunities for us to make a really cool difference. In the back, we've got some soldering stations back here so we can integrate electronics into our designs and our projects. We have a vinyl cutter, a vacuum former, and this space is accessible through a low monthly membership. It's also the space where our summer campers and others gather in the good years, right? And this year we'll be able to work virtually through our virtual hands-on series of maker camps. We're working to instill a passion for making at all ages, because that's what provides a gateway into opportunities for STEM careers, opportunities that you can access now that you know that they are here and they're available to you. So I hope that each and every one of you thinks seriously about working in a cool place like this, getting to work with cool equipment like this, and pursues your education and leans in on opportunities to be a maker at all ages, at all stages, and with everything we have at hand. All right, enjoy your day. Thank you so much for making time for us here at RCBI at Marshall University. I'm Deacon Stone, the STEM Education and Maker Programs Coordinator. The pleasure is all mine. Take care.